afternoon, ladies and gentlemen. So, as we were hearing for the last 1.5 hours, that security, data protection, identity management, right? Security end-to-end, as Sir was speaking about. So, what I wanted to talk about here today is that I'll take a portion of it because addressing the entire security domain is very difficult in 10 minutes. But what I wanted to say is that today, when we think of security, the first thing which comes to our mind is against whom we are protecting, right? So that is the first thing which comes in mind. The second point is that when we look at security, we look at a traditional security, like we build a huge perimeter kind of a security. We build impressive walls, right? Layers of security. And then also we look at signatures based kind of analogy and try to passively protect from the attackers to secure our data. So this is what we look at when we talk about security. But when I'm not talking about end-to-end, because end-to-end you talk about encryption mechanisms, you talk about a lot of devices being protected, right? And also the sustainability of the devices when there is adversaries, right? So these are the things which we need to look at when we look at end-to-end. So what I say is, as Abhinav was talking about, my friend, that proactive security. Today what is happening is it's all passive, right? Whenever there is an attack happen, there is an alarm generated or a log being created, and then immediately we look at those and find out, oh, okay, this attack has happened, now I need to protect against this attack, right? So, and also sometimes what we have seen very clearly is that they even don't know that attack has happened. Like, these are the conditions what we have seen with the customers, right? There is a one saying that either you know you have been attacked or you don't know you have been attacked. That's the only two ways which you can look at security, right? So what I wanted to talk about is the proactive security. Proactive security in terms of deception mechanisms. Today the security has moved forward, right? So what we look at is some of the deceptive techniques which we can use to protect ourselves and to protect our data from these kind of hackers who are very sophisticated. And today the hackers are not doing just for fun. There is a lot of national interest which comes in, there is a lot of money which comes in, a lot of groups which does because of some other purpose. So we need to look at all those criteria when we look at this kind of security mechanisms and what we are going to protect and how should be our protection mechanisms. So one of the things which I heard here was that when we build a house, we need to have locks and we need to like to have a police station. But what I wanted to say is, when we look at proactive security, we need to look forward and say that, for example, if a house burns and there is a picture of the house burning, instead of that we have a smoke alarm, right, which can detect and tell us before that there is a fire. That is what we talk about proactive security, right? So that is what I just wanted to highlight here. So just evolution of threats, I wanted to put it, because today the threats and the attack strategies have changed. Earlier we used to say that internal attacks are more and those are the things which we need to protect. But today it has completely changed. The external attacks are more today because of the cloud environment, because of the virtualization, because of the data centers being consolidated, right? Mobility factor, data in move. So these are the things which are actually changing it into 90% of the breaches come from outside, right? And there is a lot of statistics and 70% attacks happens on the application layer because that is where you get the entry into any of the network, where you can take any of the data out of that, right? So if you look at this slide, then I can say that the security threat landscape, sophisticated attacks, that's what I was talking about. Today, the attackers are so smart and the hackers are so smart that they evade all these security mechanisms which we are trying to put in the data center, right? They can go below that and without being noticed, they can sit in your network like persistence threats, right? And then try taking out the data out of your network. So there are so many sophisticated attacks, and today the tools which are available is available on the internet, right? Like you look at Rudy, you look at Lolaris, right? You look at any kind of the tools which you want to use. It is like a GUI based, LOI, CUI, like, right? There's those kind of IO kind of a thing which you can start an attack using an Android phone, right? As IP for like you just create IP address, DDoS attacks, right? Today, like some 3 years back, we used to see DDoS attacks as a volumetric attacks, which brings down the server. Today, we are not talking about volumetric attacks. We are talking about application level low and slow attacks, which even no one will recognize that it is a DDoS attack, right? So these are the things which we need to take care in terms of protecting our assets. So that's where it comes in. And I wanted to highlight on the complex infrastructure, because today the infrastructure is very complex, because we have virtualization, we have private cloud, we have public clouds, right? There is a lot of consolidation. So these kind of, when the virtualization world comes into play, the security also keeps changing. Because as Sir suggested, that when there is a data motion which happens between the virtualized machines. So do we see how it is protected when they move within the VMs? No, we are not aware. We only take care when the data moves from one system to another system, but we never take care when the data moves within the VMs, within the same host. So these are the things which we need to take care when we move into a virtualization world, completely. From the physical data centers, what we were talking about earlier, with having a big firewalls, with big next generation firewalls, with signature biased IPSs. So that's not the way to do it. So we need to look at it in a different perspective altogether. When we talk about, when we are moving, there is huge inflation of data, right? Because census data, IGRS, criminal record data, there is so much of data which are coming in, video, as Sir was saying about, because everything is packetized today, right? So when we look at this kind of data, then the protection mechanisms also should be different. And we need to look at proactive kind of security. That's what I just wanted to say about. And then I had put some charts here. These are some of the reports which has come out, that the cyber attacks which happen, initial attack to the initial compromise takes seconds to minutes. That is what it is required for a hacker to get into your network and start attacking and taking out the data out of your network. It is seconds to minutes. And detection of these attacks takes days to months to years. That is the difference. So where do you draw the line? Whether after the attack or you want to know before the attack. That is the key. So that is what I just wanted to put. Have you ever been deceived? We don't know. Yes, we may have been deceived once we know that it has been attacked, or we don't know whether we have been deceived, right? So there's a small quote below saying that all warfare is deception. This is a quote from Sensu. It is just one story I just wanted to say in 2 minutes is, this tag what you see is actually a deception technique which was used in 1943 World War II, when the Americans and the UK and the Canadians wanted to attack the German. Then they thought that the best way to attack is through deception. So what they did was, they just used a inflated rubber tanks, which was hardly some 90 pounds or 100 pounds, actually carried by artists, not even soldiers, near the Calais Channel. So Hitler moved all his troops from Normandy to the Calais, thinking that there's a big troop which is coming and attacking the German, right? And they used the deception of sound to give that effect of the attack kind of a thing, the war tanks moving, the soldiers walking, right? They made this deception and they didn't even shot a single fire to attack the German. They attacked from the other side, but the whole troops were pushed towards the Calais, which was this deceptive kind of a technology what we used. So what I wanted to say here is that this is what, changing the game. A famed hacker, Kevin Mitnick, wrote a book called The Art of Deception. In that he said, if deception can be used for attack, can it be used for cyber defense? Can we deceive the attackers so that they feel that they got the real data out of the network, but still they have not got the real data, it was all deceived data, what they are getting, right? That is where we need to look at in terms of attacking the attackers rather than being passive and waiting for an attack to happen. So that is where I am coming, right? So when I put this as a 5 phases of attack, then you can see that they do the reconnaissance, right? They find out, they scan and they see where is the vulnerabilities to attack, and they do a targeted attack kind of a vector. Then they attack, then they stay persistently and they steal out all the data, and then they even doesn't allow you to patch or remediate or do anything to cover that loophole. So what we have seen today in the security solutions, what we see today in the market, or when we see in the customer place, is these things will enable only after the phase 3. There is no security mechanisms which can tell me that this is what is going to happen to my network, this is the attacker who wants to steal something out of my network, and this is what he's trying to do, which if I don't protect it. Right? So these are the things which we need to look at if we really want to protect our data and be proactive. So this is what we call it as intrusion deception, wherein you detect the attacker and also what you do is you track the attacker. Right? And then you profile the attacker. And then you respond to the attacker. That means what? I have all the information of the attacker. What he wants to do in my network, right? What is the tools he has used? All those capabilities. So I just go further. So what actually happens in this deception is that whenever you access a web page, there is some vulnerability points which are inserted in the web page and sent to all the users, whoever is accessing the web page, right? We call it as a tar trap. The hackers will wait for these vulnerabilities on the web pages. What they do is once they say these values have been changed which are not the normal values, they click it. Once they click it, what we do is we tar trap them. That means we trap them saying that okay, he might be an attacker, so let me trap him, and then what we do is we start tracking him. That means we send some super cookies back to him and we start tracking him. So once we track, here I just wanted to say, earlier what we used to do is whenever we think of security, we think of IP address to be blocked, right? Like Wikipedia blocked the complete Saudi Arabia or Qatar because there was an attack and they brought down the complete network, right? So yeah, so that is what happened. So this Bertilan, I don't know whom you know about Bertilan. He is the person who actually changed the fingerprints into 11 measurements of the body to identify a person, right? But it didn't work out because of other reasons, and then the fingerprints came into place. So other one, what I wanted to say is, when we talk about signatures, we only talk about signatures like a vaccine. Because when a patient is infected, then only we look at his behavioral things and then create a vaccine. In the same way, signature is created. Not for a zero. Whenever the attack happens, a zero-day attack, then only they realize, they find out, and then they come out with their signature. So here what happens is, in this solution, you fingerprint a attacker across around 200 profiles. Right? It may be a OS, it may be a tool, it may be a device what he's using, it may be the screens, any kind of things. These kind of fingerprints are taken by the attacker. And what that does is, then we put it onto one central database. So we have all the collection of the attacker database sitting in one place. So whenever an attack happens, what happens is, this guy will actually talk to the central database and finds out whether he's an attacker or not. If he's an attacker, then immediately will come to know, you can tar trap him, and there are a lot of things which you can do to respond. Like you can delay him, you can send wrong information so that he keeps trying to hack again and again, or you can throw him out of the network. So this is something unique, which the security. For example, in a Malaysian Airlines which happened, if we had this kind of database and the immigration officers, when the passports were coming, if they can look at that, and said that, okay, this is the stolen passport, so he is the one who is the person who has stolen the passport. It would have been that kind of activity. This is similar to that in the cyber side, right? I map it to everything which comes into an attacker database and find out whether he is an attacker or not, and then allow him into the network, right? This is one. So I'll go fast. So this is known as the lookup. And the evolution of DDoS, as I was talking about, is today it is low and slow attacks. It is never a volumetric attacks. Okay, so what happens is, if you have heard about DNS amplification which happened, where what they do is they do a target IP and send a DNS query to the DNS server. And what it does is it replies back to that guy, to the targeted IP, and they amplify it by 100 times. So what happens is the target server will go down without knowing, right? So these are slow and actually slow and low attacks which happen into the DDoS kind of a solution. So there is a solution where nowadays what you see is they assign a charm values. That means when a user comes in, they give a low value. If he is good, then they increase the charm value so that he is a good person, so I allow him into the network. If he tries to do something, the charm value comes down and they throw him out of the network. So today the low and slow attacks can be stopped by using these kind of solutions, using charm values. So what I wanted to say here is, watch attackers on your website in real time, record the attack and understand how your website is attacked. So you will know also that what he tried to do when he came to attack your website, or what he wanted to steal, or what he wanted the information to be pulled out. Right? This is what it is. So what I just want to end is that security by deception is the way we need to go forward if you want to take care of the hackers, because realistically the attackers will be there who wants to gain an advantage, and realistically there will be hackers who are going to come into our networks. So we need to do this proactiveness, and we need to manage these attackers, hackers, and manage in such a way that they don't get into the network and we can know them before they go into attack. That is what this one is. But the rest of the things I couldn't cover because of the time limit. So thank you.